Hey guys, Mr. Wilson here. Today we're going to finish up the notes for the semester with systems of inequalities. At the end of the video, you should be able to find all the solutions to a system of inequality by graphing. Okay, a solution to any equation or inequality is any ordered pair that makes the equation, inequality, or system true. Okay, a solution to a system of equations is found at the intersection of two lines. Which is why there's only one solution. Okay, because lines will only meet once. A solution to a system of inequalities is found in a region of the graph created by the two lines, which is why there are infinitely many solutions. We'll say okay, excuse me, let me get this up straight. Alright. So, how many regions were created when we had one linear inequality? Yesterday we saw that there were two regions. Okay, we had one above or one below the lines. Either above or below were the regions. Okay, how many regions typically will be created when we have two linear inequalities? Will be 4. Typically there will be 4. Okay, so basically we have two lines, so two regions each, 4. And how many of those regions represent the solution to the system of inequality? 1. Okay, so let's look at that in these examples at the bottom. So first example, we have y is less than 1/2 x. Okay, remember we want to have this in slope-intercept form if possible. That means y by itself. Okay, we could say plus 0 here if that helps you out. Or minus 0, really doesn't matter. Okay, and then we'll just treat this as an equal sign at first. Okay, so our y-intercept is 0. Our slope is 1/2, so up 1 over 2, up 1 over 2, up 1 over 2. Could go down 1, left 2, down 1, left 2, down 1, left 2, if we wanted to. Okay, and so here's our first line, kind of, because remember we have to focus on is our line solid or dotted. And because its y is less than and it does not include equal to, we know our solution cannot be on the line. So our line is dotted. Dotted lines are nice because I don't need to use a straight edge as much. Okay, dotted. Second line, we have x is greater than or equal to 1. Remember, we're going to treat this just as an x equals. So x equals 1, that is a vertical line. Happens here. All the way up and down here. Everywhere where x equals 1. And that, like I said, is a vertical line. I use this. So, and it's or equal to, so I know it's a solid line. Okay? That means the solution can be on the graph. All right, now I drew both of those in before I shaded it because now shading gets a little bit more complicated, and I want to see how these lines work. So here we have y is less than 1/2 x. So that was this line. Y is less than 1/2 x. And less than means we're going to shade below. Now when I shade this, what I'm going to do is I'm going to shade, because I'm using one pen, I'm going to shade kind of neatly. So I'm going to shade below my line, but I'm just going to use horizontal lines. Okay. Here I have x is greater than or equal to 1. So greater than, we were saying to shade above greater than or below if less than, but with the vertical line there is no above or below that line, there's just that line. So greater than, if it's for this line, we have to say where the number is greater, to the right. So I'm going to shade to the right. I'm going to shade with vertical lines. Okay. Now the reason I'm shading vertically and horizontally is hopefully you can see there's a section that has vertical and horizontal shading. It's here. To the right of our x is greater than or equal to 1 line, and underneath our y is less than 1/2 x line. And so now in that area, that's where my solution is. I'm going to shade that darker. These are where all my solutions will lie. This is the region. Okay? And so now here it says give two solutions. Well, any two solutions, any 2 points that are shaded. So I could have a point on the line. Let's say I could say 1, -1 would be a solution. Or I could have a point just in the shaded region somewhere over here like 4, -2. But there are a lot of different options in here now. A lot of different options in that shaded region. Alright. Number 2. We have x is less than, or sorry, y is less than or equal to x minus 2. And so now we're going to graph this line. Alright, so -2, that's our y-intercept. We have x, our slope is 1, so we go up 1/1, up 1/1, up 1/1. I'll just keep doing this so I know my line is as straight as possible. Our next line we're going to need to put into slope-intercept form, so that means we're going to solve for y before we start graphing, but let's focus on this one first. Our line is going to be solid because it's or equal to. Okay, so I'm going to go ahead and draw that solid line. Okay, all the way through the graph. You cannot shortcut this and just make 2 dots and have your arrow in the middle, because we need to see all the possible points. Okay, now from there we are going to solve for y here, so I'm going to, let's shade this line before I move. So y is less than, I'm going to shade below this line. Okay, so I'm just going to neatly, remember this is just so I can kind of see where the shading is later. Okay. Second line I need to solve for y, so I'm going to add 4x to both sides. Add 4x, I have -2y is greater than or equal to 4x plus 2. Then I'll divide by -2. Remember with inequalities, when you multiply or divide by a negative number, we have to flip the sign. So we have -2x minus 1. So our y-intercept is at -1 here. Slope is -2, so we're going to go down 2 over 1. Down 2 over 1. Down 2 over 1. Could go up 2, left 1. Up 2, left 1, up 2, left 1, up 2, left 1. Okay, this line is also going to be solid because it's or equal to. Okay, so make sure I go through here, have all those points there. Okay, solid line. And we're going to shade beneath. So beneath this line. And so now my solutions happen where I have my crossing lines, so inside this triangle, this region is where my solutions happen. So any point inside that region will be a solution. I'm going to choose points -1, 2, sure, 0, -3 is a point. I could also go down here to like -2, -1, 2, 3, 4, 5, 6, -2, -6. Okay, that's a solution. Again, there are plenty of other solutions, but choosing those two for 2 possible solutions. Flipping to the back. Trying these, number 3, we are going to have to put both of these in the slope-intercept form. Okay, so as we do that, solving for y, I'll subtract 3x from both sides, so I have 4y is greater than or equal to -3x minus 8. And then here I'll have, let's just solve this out. I need to divide by 4. So I have y is greater than or equal to -3/4 x minus 2. Okay, that's my first line. I'll go ahead right now and just do the second line. So I have 6x minus 8y is greater than or equal to -16. I'm going to subtract 6x from both sides, so I have negative 8y is greater than or equal to negative 6x minus 16, and then I'll divide by negative 8. Remember, since I'm dividing by a negative number, now I have to flip the sign, so I have 6 over 8, which is 3/4 x plus 2. Okay? Alright, so here are my two lines. So y is greater than negative 3/4 x minus 2. Minus 2 is my y-intercept. Negative 3/4 means I'm going to go down 3 and right 4. I could also go up 3, 1, 2, 3, and left 4, 1, 2, 3, 4. Can't do that again. And put it on the graph. This will be a solid line because it's or equal to. Okay, so I'm going to draw my line through. Okay, solid line. Okay, my second line, y-intercept of 2, 1, 2. Slope of 3/4, 1, 2, 3, over 1, 2, 3, 4. You can go down 1, 2, 3, over 1, 2, 3, 4. Okay, it's also a solid line because it's or equal to. Okay. Alright, and so now some people don't like shading both lines first. They rather kind of look at the solution at one time. So let's focus on where these would be shaded. Our first line would be shaded above the line because y is greater than, so it would be above here. Our second line would be shaded below the line. So if we're just looking at this, what's above this line and below this line? Well, that's this area in here. Above the first line, below the second line. Okay, and so some people like this, it looks neater. Now, I will caution you that if you're not very good at this, then what's going to happen is that you're going to make a mistake of where your solutions are instead of just shading each one individually like we did with linear inequalities. Alright, so now the question, is 5 2 a solution? Well, let's see. 1, 2, 3, 4, 5, 1, 2. Is 5 2 a solution? The answer, yes. Okay. Alright. Last example here. We have y is greater than 3/2 x plus 4, and 6x minus 4y is greater than 8. So let's start. Plus 4, 1, 2, 3, 4. 3/2, so that means we go up 3 over 2. Could go down 3 over 2, down 3, left 2, down 3, 1, 2, 3, left 2. Alright. And now this line is going to be dotted because it's greater than, but it's not or equal to. Okay, so dotted. And now we have the shade. I like shading before. Okay. It's greater than, I'm going to shade above. Okay. My second line, I need to make sure I solve for y, so I have negative 4y greater than negative 6x plus 8. And then I'll divide by negative 4. And so y, I have to flip the sign, is less than 6 over 4 is 3/2 x minus 2. So I have minus 2 is my y-intercept. Go up 3, 1, 2, 3 over 2, 1, 2, 3 over 2, 1, 2, 3 over 2, 1, 2, 3 over 2. That's it. Okay. This line will also be dotted. Dot, 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 dot. Okay. It is less than, so I'm going to shade below. I'll shade this way. Okay, and now let's answer some questions. How many regions are in this problem? One above, one below, one above, one below. There's four, let's say there's there's actually 3 regions. We see one region here, one region here, one region here. Okay, why? Because the lines are parallel. Abbreviate parallel with those two lines. How many regions represent solutions? 0. Is this always the case? No. Okay, if we had this problem and said y is greater than 3 halves x minus 2, then we would shade it above, and then we'd have 3 regions, but we'd have one region that was the solution. Okay, so it could be parallel and still have solutions. In this case, they were parallel and didn't have solutions, but parallel lines with systems of linear inequalities don't mean no solutions. Okay, all right, so those are systems of linear inequalities. Some examples there. Hopefully now you're able to do the linear inequalities in systems, show the solutions, identify the solutions, and recognize if given points are solutions or not. All right, see ya.